guys, my name is JJ Khoza. We are doing lines. I'm going to talk about lines, nothing else, just lines on the analytical geometry. So when we talk about lines, it means I'm going to show you different types of lines. Okay? Different types of lines. On the topic of lines, of straight lines, we're going to talk about number 1, horizontal lines, number 2, vertical lines, number 3, oblique lines. Oblique lines, it means slanted lines, lines that are not flat or not vertical, but at an angle. They have a slope, right? Number 4, the derivation of a straight line. How do you find the equation of a straight line? And when you find the equation of a straight line, you need two things there. You need either 2 points, or you need a point x map y and a gradient. Okay, so let us shoot. Horizontal line, straightforward. You can see it's written in red here. A horizontal line is y equals to k. So along the y-axis we have value k. K could be 1 or 2 or 3. It could be any value. So I just selected arbitrarily k, right? And I draw a straight line that is parallel to the x-axis. And this line is a horizontal line. It is y equal to k. It could be y equal to 4, y equal to 5, or y equal to -5 for that matter. So in that way, the line would be below here. Here it's y equals to -k. You may also have another one whereby x is equals to -k. So similarly, with a vertical line, you draw a line on your x-axis parallel to the y-axis. I've also selected an arbitrary point k, so I draw a line there. On the left hand side, we know the values on the straight line is negative, on the number line is negative. So my straight line is vertical up, originating from a negative number, x equal to a negative number. So that line is vertical. I think this is clear. We move to something more interesting than this. We are talking about a line with a slope, a line with a gradient. We have spoken about a gradient, M, about its applications and how to calculate it. Now we are doing something, something nice about it. We have this general form. This is a general form of a straight line. This is called general form. General form. This is a general form. Now in the general form, we have C. C is y-intercept. What is a y-intercept? It is where a line cuts the y-axis on the Cartesian plane. So here, on this red point, is a C. How do we get C? We make x equal to 0, and here I've done it. I've taken the original form. Remember, m could be any value. You remember we calculated the value of m previously? Now, m could be any value. In place of x, I replaced with 0. I substitute with 0. Why? We're looking for a y-intercept. We make x equal to 0. So here x is equals to 0. M multiplied by 0, or any number multiplied by 0, is a 0. So we're left with C. So y is equals to C. We got it. Okay. Secondly, now it's a 10 for y to become 0. Why not? We make y equal to 0 to find x-intercepts. Therefore, we have this mx plus c equal to 0. Mx, we transpose c, we have negative c. X is equals to negative c over m. So you will always divide by a gradient anyway. Now, we have a negative number. The negative number is here. Can you see? So I join these two lines, these 2 points. When I join these 2 points, I get the line. Line y equal to mx plus c. Right. And therefore, we can also do the same thing. You can also have a c being negative. This is an algebraic matter. You can also have y is equals to negative mx plus c. You can have this condition. It means that algebraically, when you solve for it, it will tell you on its own. You'll find the value of c, you'll plot it, and when you solve for x, it's going to give you a certain value, right? You plot that value when you solve for x, and you connect the 2 points. There you go. You got the answer. So it's algebra. Okay? If you don't understand, you can send me a message. Okay? We move forward. Now I want to do something interesting, something that looks much better. Derivation. It's a derivation of the equation of a straight line, for a straight line, for a straight line. Derivation of the equation for a straight line. How do you find? We know well that the equation of a straight line is mx plus c. But how do we find this? Let us say you are given 2 points. Okay? You are given 2 points. You have a Cartesian plane, and you are given 2 points. You are given a point maybe here. You are given a point anywhere. Anywhere. It could be here. It could be there. It could be here. Anywhere. But you are going to select 2 points. Okay? So on these 2 points, it means you have point A, which has a corresponding value, corresponding coordinate YA. You have point B, XB, and a corresponding coordinate. So what do you do with these 2 points? Firstly, you can calculate gradient AB. And gradient AB, you calculate it YB, subtract YA. You find your gradient. XB, subtract XA. Right. Now we have our gradient. We are done. Right? So we are going to select one of the points to use. I select, maybe I can select B, or I can select A. Right? We have calculated the gradient. So the equation for determining a straight line is y minus y1 is equals to the gradient into x minus x1, or y minus y2 is equals to m into x minus x2. So this could be a, if you like, it could be a. This could be a b. This could be a b, right? And the gradient is the gradient of the line AB. Alright. So you have to find the gradient. Sometimes they may tell you that find the equation of a line, and that line is perpendicular to line 1. And you will know then what to do with the gradient of line 1, isn't it? Because you take the gradient of line 1 multiplied by the gradient of line 2 is equal to -1. It must be equal to -1. But you don't have maybe the gradient of line 2. So you will divide by the gradient, the other gradient. So you are going to have the gradient that you want of this particular line is equals to -1 over the gradient of the other line. So there are many ways of finding it. They can ask you in many different ways. And what I've just said now is what they could possibly ask you, because it's not easy to think of. You may forget, because the point is all about seeing that you understand the subject matter. If you did not understand what I just said, rewind. Okay, so here you decide which point to use. You decide. The gradient you may be given, or the gradient you have to calculate it yourself, or you have to figure it out. They may tell you that these two lines are parallel, so you know, okay, you are going to take the gradient of the line that is parallel to this line that you are trying to determine. Therefore, this is what we are going to do. I'm going to select a point. Whether I am given 1 point or 2 points, it does not matter. I'm going to use whichever point I feel like using. Therefore, I am going to substitute with the values here. I'm going to substitute with the value of yb here. I will take it from here. And then I will also substitute with the value of xb, and I will take it from here. So this will go there, and this will come here. So I'm going to have a number here, then I'm going to start to multiply. Here the laws of algebra are coming again. This is properties of real numbers. This is distributive property. We are going to multiply the gradient with the variable x and with this number. Here you don't substitute. This x and this y, you don't substitute anything on them. And then you are going to transpose this. This is the equation. This is it. It's either you have your own gradient that you have calculated yourself using this equation, or you will find the gradient by using perpendicular lines and say m1 it is equals to 1 over m2, or m2 is equals to 1 over m1, or you are going to use parallel lines and say the gradient of line 1 is equal to the gradient of line 2. Okay, so you use that gradient. So you have 3 methods. You are using the perpendicular principle, or you are using the parallel principle, or you are using the formula to calculate the gradient. What else could be difficult? This is simple and straightforward. Simple and straightforward. Okay guys, I hope you enjoyed this one. Please like my video, subscribe to my channel so that you get updates all the time, and share this video or my channel with your friends so that they can get a good understanding of mathematics. I am trying by all various means to make mathematics understandable. Ciao.